Today, we are diving deep into an incredible, pretty much invisible science. It's the science that keeps our whole world moving. We're talking everything from the engine in your car to the hard drive in your computer. And, funnily enough, it's also the very reason they all eventually break. So let's start with a really basic question that, affects pretty much every mechanical thing you own. Why don't things just last forever? Why do they always seem to wear out? Well, a huge part of the answer is friction. It's this constant, grinding force that, along with the wear it causes, is happening on every single surface, all around us, all the time. It never stops. But get this, there is an entire field of science dedicated to understanding and fighting this battle. It's called tribology, and basically it's the science of what happens when surfaces slide against each other, with a laser focus on friction, wear, and of course, lubrication. Okay, so to really get what's going on here, we need to zoom in. I mean, way in, down to a microscopic battlefield that you've probably never even imagined before. So here's where your mind's gonna be blown. To our eyes, a piece of polished metal looks totally smooth, right? Like glass. But if you put it under a powerful microscope, it's actually a rugged, jagged mountain range of tiny peaks and valleys. Scientists call them asperities. And that right there, that's the root of the entire problem. When you slide two of those smooth surfaces together, you're literally smashing those microscopic mountain ranges into each other. The tiny peaks crash. They lock up, they break off, they get deformed. That's friction. That's what generates all that heat. And that is exactly what causes things to wear out and eventually fail. So how in the world do we fight back against this tiny, invisible demolition derby? Well, our first and most important line of defense is lubrication. The whole point of any lubricant, whether it's the oil in your engine or some industrial grease, is actually super simple. It's all about creating a protective film that keeps those jagged, mountainous surfaces from ever actually touching each other. But, of course, it's not quite that simple. Scientists, or tribologists, they talk about it in different regimes. The dream scenario is hydrodynamic lubrication. That's where you have a nice, thick film of oil completely separating the surfaces. It's kind of like a car hydroplaning on a puddle of water. But then, on the other end of the spectrum, you have boundary lubrication. And this is the danger zone. The film is so thin that the tallest of those little mountain peaks start crashing into each other. And that's when the real damage starts. Okay, so this brings us to the really cool, futuristic part of this fight, making our lubricants way smarter by adding microscopic reinforcements. I'm not kidding. Researchers are adding all kinds of incredible stuff to oils and greases now. We're talking about tiny nanoparticles of things like silica, graphene, and even something with the amazing name carbon nanoonions. You can think of them as a microscopic special forces unit operating inside the lubricant. And the results? They are absolutely staggering. Get this. One study found that adding just 1% of silica nanoparticles to a lubricant can slash the friction between two surfaces by nearly 28%. In an engine, that means more power and better fuel efficiency. Just like that. And here's the even crazier part. That same 1% of nanoparticles cut the actual rate of wear by more than half. I mean, think about that. That means parts could potentially last twice as long. So how do they actually do it? Well, it's like they have this brilliant, multi-stage defense plan. First, some of them act like billions of microscopic ball bearings, just rolling between the surfaces. If the pressure gets too high, they might flatten out to spread the load, or even break apart to fill in the valleys and make things smoother. And the coolest part? Some of them actually decompose and chemically bond with the metal to form a brand new, super tough protective layer called a tribofoam. But hold on, because just improving the lubricant is only half the story. Scientists are now completely redesigning the battlefield itself, the actual surfaces. This is a total game changer. What if, instead of just pouring oil onto that microscopic mountain range, you could actually reshape the mountains themselves? Well, that's exactly what surface texturing is. It's about engineering these incredible microscopic patterns right onto the metal to make it naturally more slippery and a whole lot more durable. And these textures work in some really clever ways. The tiny grooves can act like little traps, catching any bits of metal that wear off, so they can't float around and cause more damage. They also create these perfect little pockets that hold onto lubricant, so the area never starves for oil. And maybe most amazing of all, as the surfaces move, these patterns can generate their own cushion of pressure that actively pushes the two surfaces apart. And the impact here?
It's just massive. Some studies have shown that putting the right texture in the right application can reduce friction by an unbelievable 75%. That could completely change the game for efficiency in everything from a giant power plant to a tiny artificial hip joint.
And, the specific shape of the texture matters a lot. Simple little circular dimples work pretty well, but the research shows that more complex, cross-shaped patterns can be 20 to 25% more effective. And now we're seeing these really exotic new designs, like tiny one-way channels inspired by the Tesla valve that are pushing performance even further by basically pumping lubricant exactly where it's needed most.
Okay, so we've been deep in the weeds of this microscopic science. Let's pull back for a second. What does all this actually mean for us in the real world? Why does this invisible battle even matter?
Oh, it matters immensely. Every single tiny victory that scientists win against friction in a lab translates directly into huge benefits for all of us. We are talking about more efficient engines that use way less fuel, products that last significantly longer before they break, and machines and systems that are just far, far more reliable.
So really, the big takeaway is that this incredibly deep and complex science is what allows our modern high-tech world to even function. From the smallest bearings spinning inside a hard drive to a massive turbine generating our electricity, tribology is the hidden hero that's keeping everything running.
And that leaves us with one last really fascinating thought to chew on. With all these incredible advances, these smart nanoparticles and intelligent surfaces, what's the ultimate endgame here? I mean, are we actually on a path to one day engineering a world where friction and wear are pretty much things of the past? Just imagine that.